Well, how's everybody doing out there? Well, welcome to day 17 of Corona Online School. So, technically, if you notice on this, I was supposed to, or I wanted to actually do this the first day, or as day one of 2.2, but I totally forgot. So, oh well. So, it doesn't matter, I guess, what order you actually do these in, but I mean, in my mind, I wanted to do them the other way, but we'll do it this way and it won't matter. So the goal for this one is we're going to study area and circumference of circles, and then use GeoGebra to do some of that, and then we're going to use some GeoGebra to talk about or areas of polygons and circumferences of polygons. So even though we have formal formulas for them and stuff like that now, I still wanted to talk about it using GeoGebra just so you can see some of the cool tools that are available and stuff. So there's a lot of GeoGebra today, so get your computer ready. You'll have a lot of fun doing graphs and stuff. So, all right. So some of these definitions we know, like diameter and radius, we've talked about them before. But circumference of a circle is basically the same thing as the perimeter for a circle. So it's like perimeter of a circle. So it's the measure around the circle. So if you were to walk around the circle and kind of keep track with a step counter or whatever, that would be the measure that we're looking for. So the measure around the circle. So diameter, remember, it's the longest chord of the circle. And remember, it has to go through the center. And then radius is just, any point from the center touching the circle. So it's a line segment from the center to any point on the circle. All right. So the first activity we're going to do, so normally we would do this in class. So since we're not in class, we're going to actually we're going to improvise and do this at home. So this is actually going to be the collaboration for the day. So your goal is you need to find something that's round at your house and measure it. And so I'm going to have a big table set up for you guys so you can write down what you actually measured. So you want to measure the circumference, so around the circle. So if you need to, if you don't have like a ruler that's flexible, just get a piece of string or something like that and then measure it against a ruler. And so everything that we're going to do, we're going to do in centimeters in this case. I think I wrote that somewhere. So do everything in centimeters. So you're going to measure the circumference, you're going to measure the diameter. So again, make sure when you're measuring the diameter, make sure you go through the center. And then what you want to do is calculate the ratio of the circumference to the diameter. So for us, normally we'd fill all these out. So what you'll want to do is come back later to the collaboration and check some other people's and then fill in 3 more that people posted online. So that way you can share. So by the time we're done, we should have at least 18 or 19 different circular objects that we've measured. So once you've got enough of them to kind of judge, then go through and answer part A and part B and see if you can figure that out. And using those things, can you come up with a formula for the circumference of a circle? So I'm not going to give it to you right now. So like I said, hopefully from measuring, you'll be able to figure out what this guy is. All right, so next what we want to do is we want to talk about circumference, but using it as a way to estimate, or using polygons as a way to estimate the circumference of circles in this case. So I've drawn 2 pictures here of a regular polygon. So we've got a regular triangle and we've got a regular square. And so if you imagine, again, when we're talking about the perimeter, so we're using this to estimate this. So looking at it right away, you're probably going, well, that's probably the worst way to estimate things ever. And that's true. So especially for these smaller shapes. So it will get a little bit better. So what I want you to do is kind of just measure, use a ruler or something like that. Find the perimeter of the triangle, find the perimeter of the square, and then I went ahead and told you ahead of time the radius of this circle is 4 centimeters. So you can use the formula from above, or if you want, you can just take a piece of string, wrap around the circle, and measure it that way. And get an idea of compare these guys and see how well you think they did. And then what we want to do is we want to increase the number of sides of the polygon and see what happens as we increase it if it gets a little bit better. So let me show you on GeoGebra how you're going to have to do this just to make sure it works. So make sure you're following along with the video and stuff. So I'm on the app version. If you're on the computer, it should look pretty much the same anyway. So the goal is, what I want to do is I'm going to make my polygon. So the first one you guys are going to make is an 8-sided polygon. So I'm going to do a 6, so that way I don't take away from what you'll do on the table. So what we want to do is we want to scroll down. So don't use the polygon one that we see up here. We want to look for regular polygon. So if we look on the left-hand side, we've got regular polygon right here. And so the way this works is if I click on it, oops, well, now I got the help pulled up. Hold on. Oh, geez. Hold on. All right, now I'm butchering this up completely. So with regular polygon, what you want to do is, I think it tells you on the computer, you have to pick 2 points. And so as you increase sides, you want to put them pretty close together. Otherwise, the circle you're going to make is going to be humongous, which is fine because you can zoom in and zoom out. So I'm going to put mine relatively close together. And so then it says, well, how many sides do you want your polygon to have? So I want it to be a 6-sided polygon. So if I click OK, it automatically makes it for me, which is very cool. And so now what we can do is we can actually figure out both the perimeter and the area. Now in this case, I think, do I just want the perimeter or do I want the area? So I just want the perimeter. So you could figure out both. And so if you notice, the whole thing's highlighted. So if I go up to distance or length and I click on distance or length, if I just click in the middle of this polygon, it tells me exactly what the perimeter is, which is kind of cool. So I don't have to actually click each individual side or anything like that. So I'm going to zoom this up just a little bit to make it a little bit bigger. Oops. There we go. So now what I want to do is I want to make a circle that has all these points on the circle itself. So this one we have to do a little creative stuff on to make this happen, because we want to eventually use circle with the center through a point, but we need to find the center first of this hexagon. So what we have to do is actually use like the line segment tool and intersect a few of these opposite vertices so we can figure out where the center of our circle is going to be. So now that I've done that, now I know where the center of my circle needs to be. So now I can click on the center, circle with center through point. And so you click on the center first, and then you just click on any point, and it magically, draws the circle for you. And so in this case, notice this picture looks a lot better than any of these pictures, because notice the big gaps that we've got. I've got, whoops, where'd my pen go? So I've got all this gap here that I'm kind of missing, that I'm not touching the graph. But notice on my new drawing that I've got, there's a lot less gap. So, I'm still missing it, but it's definitely going to be a better approximation than the original one. So now I'm going to do the same thing. I want to find the circumference of the circle. So again, I go to distance or length, and then this time click on the circle. And so it tells me my circumference of my circle is 8.7. So not that much difference between the polygon and the circle. So it's only 4/10 off, which isn't too bad. The other ones are probably much worse, and you'll notice that when you calculate them. So now do the same thing, for 8 sides, I think 10 sides, 15 sides, and 20 sides. And then just kind of notice what happens as you increase the number of sides. Do we get a better approximation for the circumference? Do we get a worse approximation? So just kind of note that in the table. So, all right, does anybody have any questions or anything about how to use GeoGebra to answer practice 2? All right, hearing none, I'm moving on. So in this case, for practice 3, we want to estimate circles. And so what we're going to do, estimate the area of circles. And so what we're going to do is actually kind of use area model to do this. And so what you're going to do is on a piece of graph paper, draw 6 circles. So use a compass so that way it's actually accurate and stuff like that. Or if you don't have a compass, you could draw your 6 circles on GeoGebra too. You're going to do that eventually anyway. So it's up to you. And so the goal is what we're doing is I'm counting the number of blocks inside and kind of the number of blocks that are on the outside. So what I need to do when I'm counting these is if the circle crosses any, let me outline this circle. If the circle goes through any box, then I don't want to count that as part of the inner area. So even though like this part here, it barely goes through a box, I still can't count that box as part of the inner area. Same thing here. Like I could try to count part of a box, but since I'm only counting full boxes, that's why our inner area is just this nice 4x4 square. And then same thing on our outer area. So like in this case, this guy over here, even though only a little bit of it goes through the box, I have to count the whole box as part of my outer area. And so what I've done, so this was a circle of radius 3 in this case. And so our inner area was this 4x4 square, which gave us our area of 16. Our blue is the combined area, so it's the orange plus the blue together. And so that's a 6x6 box. And so that gave us a combined area of 36. And so then I took their average, so that's just 36 plus 16 divided by 2. And that gave me my 26. And then what I did is I took the ratio of the average area to the radius, and that's where I got my 2.89 from. So your goal is to do the same thing, except make your circles much bigger. So like 3 is really too small. So I mean 5 is actually even a little bit too small. So if you can, shoot for like 6, 8, 10, as big as circles as you can actually make. You're going to get a more accurate table than what I've got here. And so then you're going to do the same thing, kind of, shade in the boxes inside that are totally inside the circle, and then shade the boxes on the outside that are totally on the outside of the circle, calculate their areas, combine them, take the ratio, and then see what you get. And so hopefully you'll notice something, if your circles are big enough, you'll notice that it's a kind of approaching a certain number. So again, I'll kind of leave that for you guys to work on. So if you get stuck or have any questions about it, just let me know. I'll be around all day. And so finally, 4, we want to do more GeoGebra stuff. So in this case, what we're going to do is recreate the same circles that we made before. But in this case, what we want to do is find the actual area and the actual circumference of these circles in this case. And so again, what we're going to do is kind of do like I did before. Let me delete everything here, or clear it out. Let's see, clear all. So in this case, let me just draw a random circle. And so if I wanted to find the distance of this circle, again, I would do the distance or length and just hit on the circle itself. So if I want to find the area, I can just click inside. Oh, let me do the inside. Let me see, how do I fill it? Oh, so I can just touch the line. So if I touch the line on the circle, that'll give me the area. So in this case, I can see my circumference is 43 and my area is 147. And so these are exact measurements as opposed to what we're doing otherwise with the approximation. So I think, if I'm not mistaken, that's the only commands you need for GeoGebra this time. So again, if you're having trouble finding them or you get stuck or anything like that, just let me know. But then when you find these guys out, you pick the radius because you drew these circles originally. So draw the radius, write down the actual circumference from GeoGebra, write down the actual area from GeoGebra, and then the last 2, what we're doing is we're just copying the chart from the previous, so the last 2 things from the previous, just so we can compare how close the actual area is to the estimated area that we were doing and stuff. So, and then from there, again, just kind of answer these questions, and hopefully from this point on, we'll actually know what the formula for the area of the circle is, so we can write that down there. And then finally, oh, so this one just has you using the formula. So again, these are the same 6 circles that you decided to draw on the graph paper. So again, this is going to be our circumference from GeoGebra, our area from GeoGebra, which you can copy from above. And then now we want to use the formula for circumference and the formula for area to make sure that they actually match up exactly in this case. So it gives you a little practice with GeoGebra and the formulas both. All right, so that's all for circles. So now what I want you to do, and this is, I wanted you to do this before you knew the formulas for all these guys, but that's okay, we'll do it this way. So in this case, what we want to do is we want to draw some different shapes, triangles, trapezoids, parallelograms, just so we can hopefully notice why it's a little tricky to find the area of these guys and why it's hard to find the perimeter. So hopefully you'll notice when you draw them where the complication comes in and why it's a little tricky to try to figure out the perimeter. We know the perimeter of a square and rectangle and area are both pretty easy. So what's the difference? Why is triangles, parallelograms, and trapezoids a little bit harder to figure out, like the perimeter and stuff like that on? And so in this case, notice I've got a grid view up here. So let me show you how you can turn the grid on just so you can make it look more like what you want it to look like on GeoGebra. So let me clear this out again. So if I go over here to settings, so I think on yours it'll pop over on the right hand side. What you want to do is you want to click on show grid. And I might not want that fine of a grid. I may just want the major grid lines like that, so that way it looks a little bit better. But then what I can do, and the way this is going to come in handy is, so go back to this. Oh. So let me undo the settings here. There we go. Oh, now I undid it. There we go. So the reason you want to pull the grid up is so that way when you're drawing your triangles or whatever you're drawing, you can translate them over to the picture so you can see what's going on. So in this case, I want to use the polygon tool because I don't want to make regular polygons. And so what you do is you actually just kind of click on a point. That was bad, like, because we want to click on a corner. And so depending on how many triangles or how many shapes you're trying to make, that's how many points you'll have to do. So like for me, I'm going to do a triangle first. So what you want to do is just draw the triangle, and it can look, oh, I went too far. It can be anywhere you want. So the main thing is when you're done, you go back to the beginning point, so that way it closes it out for you and then it finishes it. So there's my triangle that I drew. And again, now that I've got it on there, all I have to do is click distance, click on the side, and that'll tell me the distance. Well, that actually just gave me the length of that side. If I click on the middle, it'll give me the perimeter of the whole thing. Or if I click on individual lines, it'll give me just the distance of those lines. So if you want to add them up, you can do it that way. Same thing with area. If I just click on the middle of the area, it's going to give me the whole area of the triangle without having to do anything else. So again, this is a lot of playing around with GeoGebra, just kind of having some fun, learning some new commands and stuff. So the last few practice problems, that's all that is just, area and perimeter of a parallelogram, area and perimeter of a trapezoid. So again, play around with it, have fun. If you get stuck or you have any questions or anything like that, just let me know. Otherwise, I'll be around all day tomorrow, so good luck.